Hey there, everybody. How's it going? Let's see. Yeah, today is going to be uh possibly 3 hour stream. I did promise 3 hours, so I want to stick to my word, but I also have a headache and I'm tired. So it's gonna be at least 2 hours, you know. My goal is three, you know. Um, but yeah, anyone from Superhero Life 3 here? It's 151. There are 151 people in Superhero Life 3? That doesn't make sense. Now I'm curious. Now it's 25. I knew better. I'm not saying you tricked me. I'm just guessing I misunderstood what you meant. Though I guess you did trick me if you were trying to trick me. So I don't know. Hey there, Chill. Thank you for stopping by. Kato, how's it going? Ah, okay. Your roleplay name is 151. That makes more sense. That makes a lot more sense than 150 people are in Superhero Life 3. Has it been like that since like what, 2020? Let's see. Crazy how quick time flies. Because I say 2020, but it doesn't really register in my head that that was 4 years ago. But it was a whole other lifetime, really. Hmm. Like COVID-19, that started in 2019, technically towards the end of it. Like, but I feel like the idea that COVID-19 is half a decade ago, it doesn't feel right, you know? Well, I guess it lasted a lot longer than 2019, of course, but arguments that it's never actually went away, now that I think about it, but still. Okay, so where did I put that one guide? Here it is. Okay, so we are going to try to get this triangle to have windows. Um, I'd like to try Linux, but just not ready. Hmm. Also, we should probably do a thing. I think it's especially important for this one, but we should probably do it in general, where the we actually adapt the floor height. Okay, so local floor dot height. We should do like the goal floor height, and then we should have an actual floor height. So local floors is equal to mat dot round. Let's see, wedge height by goal floor height. Local actual floor height is equal to um, wedge height divided by floors. Nice. And so now we just need to find examples of this and replace it with, the actual floor height. Okay, see, that's better. Let's see, what else is there? Okay, so we have this part more or less set up where every single one of these ends up being more or less on the line. You know, like, so with that in mind, we should be able to do, let me just also verify they can handle like tilting and stuff. Yeah, no, that still works. Okay. But yeah, okay, it looks like I haven't been paying attention to the chat. Apologies. I haven't I haven't attended a stream in a while. What's going on? So we've replaced a lot of the buildings with these sort of procedurally generated ones, so you can tell when like we turn it off and on. But like we use procedural generation to decorate these different buildings essentially, and yeah, I think it's looking all right. Yeah, yeah, and now we're learning how to do this so that we can do the weirder shaped buildings. You know? Yeah, the so that'll be fun. Thank you. Yeah, no, I'm pretty happy with how things are turning out as well. Like when we're also we're gonna swap over this technology as well to the lower part of it. You know, so we can start having street level things. But I think that the map's starting to come together, especially this area. I think that like literally like this view right here is pretty close to what I want. I should probably swap this out with an actual building at some point, but um, you know, still that's it's good. Let me actually, I really liked how the goal, the tower height thing worked. Okay, okay, so ledge full height. Okay, so we'll just do it like that. And size dot y. Okay, I didn't reuse that. Didn't reuse that. Good. Okay, so now we just go through and we replace every instance with actual floor height. Goal floor height, goal floor height, actual floor height. Okay, so that should change a few things, but hopefully nothing too crazy. It should hopefully fix this area. Um, actually, wait, for that we're gonna have to we're going to have to be a little bit smarter with how we do ledges. So the ledges, where are the ledges at? Okay, so render block tower, ledge full height. Okay, so ledge full height is, we should have an edge case for, okay, so how many different ledge areas are there? Is there just one? Okay, so local height. Let me move this across a few different dimensions. Okay, a few different lines, sorry. Okay, so we have the ledge full height there. Now, floor index is equal to 0. Local equals this. And if, okay, so if floor index equals, then we should probably also support this for when it's 1, because I'm almost certain it's going to be going below it, right? But we'll just do this for now. What's my opinion on beans? I'm doing, oh, Heroes too. He says, how's it going? Is in my phone the train? I'm doing my best. I do like trains. I also understand the reference. Um, let's see. My opinion on beans? I like them. I mean, I'm in Brazil. I'd be pretty much in trouble if I didn't like them. Um, let's see. Anyone know how to stand heroic pose while walking around? I've seen many people do. Um, let's see. I think a lot of it's just like posture, right? Just standing up straight. I don't know. Walk in front of a mirror a few times. See how that feels. Um, use super speed while in the pose. Yeah, being able to super speed, but also just T posing. Just yeah. That I think that's the way to go. That's how you really show that you're like the main character. Okay, so ledge size. Um, let's local. Okay, so we're going to actually do a thing where final final height equals ledge full height, local final offset equals 0. And what we're going to do is we're going to swap out this and add this, hopefully, to, okay, so if we're at the top and then we should actually have it should just be the top part of it. So let's see, so that would be equals full, let's see, actual floor height minus window. All right, so minus, okay, so let's see, so actual floor height minus the window height, which would be tower config dot window dot height. Did I do any window height changes? Size? Not really. Okay, so ledge full height. So minus tower config dot window height. What else was it? Minus ledge full height. No, that's not right. Oh wait, no, I got it. So what we got to do is then we just have then the offset will now be final offset is equals the ledge full. Okay, we need to actually do this. Okay, so final height. Okay, so ledge full height times 0.5. So we subtract the minus the. So we subtract the full height of the ledge. Hey there, Calu. Thank you for stopping by. Hey, person, how's it going? Let's see. Yeah. Oh, that I thank you, Joe. I appreciate it. Yeah. Let's see. So final offset. Headache. Okay. So final offset. So we subtract that. Then we add the floor height plus actual floor height. Then we subtract the final height times 0.5. Okay. And in this case, let's just see how that goes. It's not perfect. Okay. So if final offset or final height is over 0, then I'm going to add it here. Let's try this. Oh, it's because it's going down. It starts from the top and goes down. Okay, so then we'd actually want this to be this. Let's try that. Okay, well, we successfully got it to not appear at all. Okay, so let me think. So we have the offset should really just be the full height minus the final height, right? The final height minus full height. Let's try that. Okay, now let's just do something arbitrary, like setting it to 2. I just want to see what we're even dealing with here. Okay, so looks like it moved it up 2. So assuming 2, okay, so what we need to do is we need to flip this. Actually, wait, what is the ledge height even for this building? Might just be that it's taller. Ledge height for, no, it's smaller. So, okay, so minus 2. If I just make this 0, what happens? Okay, so making it 0 actually just puts it aligned with the top no matter what. Plus a little bit of space. I don't know what that's about. Okay. What's the initial offset thing? Okay, so we need to move the initial offset to be here. And we need to replace that with this final height thing, right? Hmm. Let's see how this ends up looking. Hey there, Zenith. Oh, I'm sorry to hear school's been stressing you, person. Keep it up. It's good practice for stuff long term. Though it's also not everything. So don't get too much in your own head. But yeah, it's it's a process. You want to find that balancing act between caring enough that you get the most out of it, but also not letting it ruin your life. And personally, I just graduated before I mastered that balance. All right, how about this? So that got it aligned with that part. Let's see how that worked up here. Also aligned it up here. Okay, so it seems like we found the right magic numbers to combine together to get it to align with the top. Question is, how do we get it to, because we want the windows to be there still, so we have to add one back. So maybe, let's see how this works. All right, I think we've done it. We've gotten the, dang it, looks like we got to do it twice. Let's try that. Dang it, we were so close. Hmm. Let me try readjusting the center building a bit. It might be an issue of just getting them to align. Okay, that looks pretty close. Yay, we did it. Nice. Okay, so now that we have that working, let's okay, let's actually do two things. The first one is we're going to reduce this to that. And some of you are asking, CJ, what are you doing? And also, aren't we supposed to be working on the wedge? And the answer to the wedge question is yes. I'm just bad at this. But for this part, though, I think that'll be pretty cool. So what we're going to do is we're going to add a tower guide tag to this, and then start messing around with the, okay, so wedge depth, 1, floor height, 12, window height, 6, pillar depth, 0.5. Okay, nice, yay. So now that we have this, let's start matching the different materials. Okay, so we have, actually, let's rename these to guides. Yeah, yeah. No. Ideally, I would have coded it in a way where I could still understand what was going on, but occasionally you just have to like just start plugging in random numbers. I guess you don't have to do that, but I do that because it works in the short term. And in the long term, we're gonna have to do a bigger refactor anyway, so why stress about it? Okay. Okay, so let's see, what else is there? So there is so salt. So this is actually salt material. Okay, so salt, veg material. Oh no, I should have put these as this. Then this should have been salt. And now let's try that. Okay, beautiful. How many floors should we have here? I think we should have 2. So let's go 14. Nice, nice. The pillars. Yeah, I'm fine with the pillars being used as a. Okay. Hmm. Let's see. How did we do this layering before? So I want the window height to be a little bit higher. So make that 8. Also, the width doesn't need to be as big. So we can do 14. Hey there, Wolf Gamer. Yeah, no, thank you, thank you. I think it's coming along quite nicely too. Yeah, Kato, yes, it's made out of sodium chloride. You mean salt? Yeah, or assuming that was a reference to the Jerry Neutron meme, but maybe not. I am old. Okay, so the pillar width. Hmm. Does this look better when the pillars are like the same pillar ledge depth? Hmm. All right, so marble wall. Okay, so let's try making the guides. Okay, so we have a marble wall, so ledge material. No, marble there. One point, and we need to use the actual material variant that we had on the other one. So okay, so guide, marble wall, which one was it? Ledge material? Yeah, there it is. No, I did that wrong. I need to copy this, and then I need to assign it here on the guide. Yay! And then I need to regret my decision because that doesn't look as good as I thought it would. Oh well. Okay. I think I am going to change the color slightly, but not anything too major. Hey, congrats, Wolf. Yeah, I think that okay, let me yes, let me try darkening the ledges a bit to make the pillars stand out a bit more. Might just be what we end up having to do. That doesn't look bad. Let me change the window width. Okay, it's a little bit better. Okay. Okay. Nice. So that's looking all right. Beautiful. Okay, nice. We did it. Okay, I'm just gonna save our work. Better height handling. Okay, nice. Okay, so yeah, so we've added this decoration to the edge. Let's actually make this pop out a little bit more, like 1.2 or something. Maybe we can just make the 0.5 and 1, and that should fit all right. Nah, no interiors right now. Sorry. I will at some point, I promise. Mm, okay. This looks all right. I'm going to change the reflectance a bit. Because this is like a government building windows, you know? Doesn't got to be anything too crazy. Okay, we're going to do this one really quick. Because it's not, I'm just looking at like, technically we could, hook that up. Okay, name. All right. Uh, guide. Okay, so how about, okay, so ledge height, so 12, let's go to 14. Let's have the window height be 10. Okay, that was a mistake. 8. Okay, we're gonna have that be 8. Um, let's see. Well, okay, so 10. Let's make the actual pillars around like 0.5. No, that's depth. I guess 0.5 isn't bad, but what am I doing? Pillar width. So I'm looking for. So 0.5, 1. Somebody make a top view map from watching these streams? Yeah, you probably could. I'll make it easier. Here's here's your map. Okay, so what about um? Okay, so I think this should be so ledge depth. We'll do like 1. Okay, and let's just make it a metal, metal, metal. Let's darken it a bit. Okay, yeah, it's fine. Um, let's make it flush with the windows. So guide. Okay. Hospital. Okay. So let's modify the width of the windows a little. We just got to make it fit the. Okay, that works. Okay. Yeah, that looks good. Woo. Okay. But let's modify the color of it because we want it to be a little bit more like, a little bit less cheerful. Should have dark windows. I feel like that. I feel like that it should have taller ledges, you know. Window height 8. That looks a bit better. Oh, I do have to adjust the window height a little bit to make it fit. Hold on. Is this? Are these not centered? Huh. Interesting. Yeah, I was like, why is this not lining up? Okay, so let's center that. Okay. So then with the guide, okay, that works. Yay. All right. Nice. I think all black is interesting in theory, but oftentimes when you're actually doing graphics, you'd be surprised how much something that's considered, black is actually like a dark purple or dark blue. Um, it's just when something's completely pitch black, it doesn't show up very well. And so I would prefer to have it be some color other than pitch black. Like look at the Syndicorp Tower in Superhero Life 3. It's cool, but you can't actually tell inside the throne room, for instance. It's kind of hard to see what's going on. I think you can accentuate with neon. That's good, but I'm of the opinion that you could just accentuate with neon something that you could also see. It's like neon is the frosting of a cyberpunk landscape, and I think that making it pitch black is kind of robs you of the cake. Um, so yeah. Okay. Okay. So now let's do this part. Um, hmm. Now I remember why I was doing all the other stuff because this is going to be miserable. I'm just sitting here thinking through like all the little math I have to do to like slice each of these in a way which makes sense. Uh, this is gonna suck. Ugh. I wish Roblox fixed its union operation things because that would actually be helpful right here. But well, no, I should do this the right way. No, I shouldn't do it with the unions because that won't scale. That'll be the performance nightmare once you do it on like 100 of these at once. Okay. Let's just start by creating the, you know, okay. Okay. So we've made a, right, first let's close the block tower code. Now we're going to make a window in the same way we did before. I said literally as I finished closing the other one. Okay, so we're gonna copy that. We're going to size CF. Um, okay, this is partially true. I'm going to do size, the window thickness. We're going to actually times vector 3 dot new 0, 1, 1, and we're going to make it a wedge part. But everything else should more or less show up. So transparency is equal to 1. Actually, I believe we're saying that elsewhere, so we can just remove that line. Okay, so we have the window. So now that we have the window, we have to just start adding the bars. Also, I'm not adding support for the ledges. Not the ledges. The corners. Oh no, but maybe I should. No, I'm not, because that's going to be miserable around here. But maybe I should. Mm, Yeah, no, that looked good here. Okay, that's annoying. That is annoying. Yeah, Pythagoras. Yeah, Pythagoras. That's going to be the least of our worries. Oh, that theorem actually is kind of easy to visualize at the end of the day. We're going to have to do a bunch of slices through these different shapes. We're going to convert basically a rectangle into a some combo of a wedge and a triangle. Okay. Um, okay. Let's do this. So let's where did that go? Okay, here it is. Yeah. Okay, so we have a has corner pillars, and it looks like that already natively supports. So okay, cool. Um, okay, so that should actually be. mm, You can see that's messed up the calculations for the line because it doesn't support its sinking. Okay, so if I wanted to, so if I wanted to make it go inwards this much, oh, this is headache. This is torture. Okay, okay, let's, because we basically need to shrink the entire thing by like that amount for this to work. So we need to figure out how much do we shrink this top part to make it start working with the, I really just shouldn't support corners. This is hard enough without it. Thank you, y'all. I appreciate it. It's good. It's good to have support as I try to tackle this. Because like when it works really well. You know, so if we can get this working here, we can get this working here and here. And yeah, and I think that'll be a cool bit of functionality to have just in our back pocket. I don't know. We'll see. We will see. Okay, so what was I doing here? Thank you, y'all. Team K. Okay, I'm just gonna do this the simple, stupid way where I reduce the size by if it has the okay, so render wedge wall. Um, okay, so I'm just gonna assume in the scenario where um, okay, so we're just gonna do it like this, where the tower config. Okay, so how did we approach the logic of this before? It would sort of bump out. Let's not do it that way. Let's just shrink the overall part by that amount. And we're going to start by having the, okay, so if tower config dot hat dot dot pillar dot has corner pillars, then end. Okay, so let's figure this out. So we have, this part going in. So we're reducing the size of it by, so size equals size dot x, or size minus vector3 dot new tower config dot pillar dot width. That's pretty easy. In fact, we want to do it by that times 2. But how? But wait, we're not doing it by x. We're doing it by z. Okay, because this is a wedge and the axes are flipped. Okay. I feel like y'all need like a secret, like, handshake, the or like a superhero theme. Yeah, yeah. X-Men 98 is cool, but I prefer Team K. Okay, so how about, and then we're going to have the C frame. Okay, so now, okay, we need to remove the other references because this is going to cause me a headache. Okay, so has corner pillars, where is that actually happen again? Okay. If it has corner pillar, then, okay, so that might actually have simplified our work a decent amount. Okay. No, it is still just a little bit off. That's frustrating. Why is it like that? Why am I subtracting 2 here? Maybe I was multiplying it by something earlier. Okay. Yeah, okay, so that now fits. And let's actually just start by creating those pillars now. Okay, so pillar. Okay, so we're gonna do the pillar part now. For we're just gonna make a function called draw pillar. Draw pillar. C frame. Okay, so now I should probably just make this a general like thing, I don't know. We'll get around to that. We're gonna have to refactor the main one at some point. So look forward to that. So size, I, number. Let's just do name instead. Let's make it optional. So if name, then name, else pillar.name. Beautiful. Offset magnitude. Well, we're just going to be setting it to this C frame here. Oh no, I shouldn't have used these as global names. That's going to be a headache. Okay, I'm just going to move that down. No issues. Beautiful. Draw pillar. Yeah, this looks good. Looks good. Okay, so now we can do a, okay, so the first pillar would be to the left. Local left pillar size. Vector3.new. So the pillar width would be that. Pillar height would be the full size, I'm assuming. Oh, no, but we wouldn't. Oh, no. Okay, we're going to have to be a little bit smarter with that. So we're going to have the left pillar size be this size, size.y. All makes sense now. Yeah, I see y'all are building some new lore over there. Okay, so I'm surprised we have 12 concurrent viewers for what to me appears to be debugging a headache of a problem. All right, but I can also see like it is cool seeing the city in the background just like changing with code. But like this is why you want like if you're a builder, I reject that builders should not learn how to code. Like I was a builder at first. Coding is just a skill, and being able to code unlocks so many building opportunities. Allows you saves you so much time. Like I don't know, it boggles the mind when like okay, like you could learn this coding stuff, and now you never have to set this again. You know, you can just write it up. It's I think that you know it's never too late to start learning how to program. Save yourself a ton of pain. Okay, so left pillar size.y, tower config pillar.depth times 2. Trying to figure out, is there ever a reason why we'd want to have this go through all the way? Because I cannot think of one. So maybe let's just have pillar depth should always be 0, you know? Okay, so now the size local left, actually, let's just make this its own little domain. That way we can, okay, so pillar size, where CF is equal to CF times cframe.new 0, 0, 0, size dot x divided, no, size dot, let's see, it would be size dot z minus size dot z times cframe.new pillar size dot x divided by 2 times cframe dot angles math dot rad 90. Okay, I know I was just like learning to code is easy. I'm actually very proud that I was able to do this logic in my head. C-frame multiplication. But anyone who also knows how to do it won't be impressed. But I'm proud. So draw pillar, pillar CF, pillar size, left pillar. Okay, let's try this. Let's see how it goes. Oof, I got it off. Okay, so we are going to have to do it that way. Though that one isn't so much the math being wrong as my understanding of the mesh. Okay, but okay, so we got that. That's good. Proud of us. Okay. We should have this go all the way to the top. Well, let's see, like what would be, because this hasn't lowered the, it has actually made it steeper. So we need to actually, okay, we need to think this through a bit more. So, okay, so how much, if we wanted it to sink down this much, to sink inwards this much, we would actually have to do, so, so multiply. Okay, let's see. Okay. Try import child. Excellent idea. I really shouldn't have taken a shortcut by reducing it by that much. Okay, so yeah, I appreciate you at least being willing to listen, Cato. Yeah, I just tried to drink an empty glass. Very disappointing. Mm, okay, so what's the what? How do I best reduce this? Okay, let's start by getting the. Okay, so instead of just reducing it by that much in every direction, how about let's go with local. What was that angle one we found? Cutoff angle. Okay, so local height reduction is equal to 0. Okay, we're going to do the logic here. Okay, so height reduction should be the size dot z and size dot y. And so then we're going to do some pretty basic trigonometry. Okay, so if we have a new reduced, okay, so let's see. Oh, width is equal to size dot x minus the width. So now we can Let's just call this delta width. Okay, so if we want to find the opposite and adjacent, TOA, tangent. Okay, so the opposite side would be the, oh, so adjacent would be the size dot z minus delta width. CJ, what's 9 plus 10? I don't know, man. I don't know. I feel like it. I'm not gonna like the answer. Just don't say something that'll get you in a timeout. Oh, Wolf Gamer, looks like you let the cat out of the bag. 2. Got okay. Is this a binary thing, like, or is this just complete? Well, what's the logic for 2? Okay, so because admittedly, that was not the answer I would have guessed. Ah, I see. Cato coming in with the JavaScript method. Um, let's see. So adjacent. So then op is equal to math dot tangent angle times. So I want to get the opposite. Oh, I have to multiply it by the adjacent. Op height reduction equals size dot y minus op, which should hopefully it's something quite nice. Hmm. That looks okay, I think. Okay, so we'll draw okay, so that should work. I'm a green function. Am I skibbity? Uh, mm, I think. I don't know. That's a positive one. There was the I just want to be your Sigma TikTok, and they seem to use skibbity in a positive way. But also, I'm just y'all lost me a long time ago. Like the next generation moves way too quickly for my weak mind. Uh, um, okay, so local pillar tip size is equal to vector3.new pillar size dot x height reduction pillar size dot z equal pillar tip cf is equal to pillar cf times cframe dot new pillar size dot y divided by 2 times cframe dot new pillar tip size y. Can't believe you'd call me that. I'm never going to trust a person again. Then I'll truly be Sigma. Okay, let's try this and see how that looks. Assertion failed. 250. Oh, wait. That's on me. Oh, wait. Can I just do this the easy way? If x, z, and I need to rotate it. Okay. Angles 0, 0, 0. Match.rad 90. Let's see how this looks. Usually I would have I would use both my screens to actually just I type in the code and save and then look, but because we're on stream and I want to see the chat, I am only using one screen right now. Okay, so we can tell this doesn't look right. So we got this part wrong because what we want to do is we want to make it so that this is the same angle, you know? So we messed up this part somehow. Okay, so let's try this again. And instead we're going to do it the opposite direction where we're going to provide so the adjacent should instead just be the pillar width. Okay, so the adjacent is the pillar width. And let's try, and then let's try that. Much better. Okay, yeah, so when we just think about it as the tip of the pillar, then that actually works out a lot better. Now, though, we have an issue in the sense that we need to reduce the this again. Okay, because we got this part down. You know, we've got that flush with it. But how do we actually add this part here? So, okay, so if we assume, oh wait, should should I be multiplying this up? So what should be what should the original goal be? Should it be? Wait, let me do times 0.5 for a second. So we want this to this would imply that we actually want it to sink down more. Okay, so how would we decide how much we want it to sink down more? Because we have that angle. Okay, so we have the differences in hypotenuse. It's not even the hypotenuse though, it's like the inverse one. So if we convert this into two different right triangles, we're bringing it inwards one. No, we're pushing it out. Okay, let's just add the other side first, and then I think that'll make things a little bit clearer. Okay, so so right pillar tip, and we're gonna have the size there. Let's try that. I did that wrong. Okay, so the C-frame, where do I actually offset the height? There it is. Okay. All right, yay. Almost yay. So we need to bump it one more this way. Yay. Okay. So by this logic, we actually just want to do it twice. We want to reduce the size of it by 2, because then no, but we want to but then that okay, so how about at the end of it we're going to multiply it by 2, and everyone's going to agree that that's the cool way to do things. All right, and no, but that didn't work. Okay, it's because so size minus equals vector3 dot new 0, 0, 0, height reduction. Okay, just so I don't remove it later thinking, why did I do that twice? Okay, yay. So now we should have, what happened here? Oh, it's because we didn't adjust the CF times equals C-frame dot new 0, 0, 0, negative height reduction times 2 again. Okay, beautiful. So now we have it reducing by that much, just to make sure that this still works when, okay, so does this still work when I has corner pillars? Yes, okay, beautiful. All right, so now this next part's easy, hopefully. Um, okay, so do and okay, so now we just have to create a are these the same length? Yeah, they are. Okay, so I just need to now make a, we're going to put a little, what are we talking about? What's going on, guys? Oh no. Oh, okay. Actually, I know if God's real, and I'm just not telling everyone as a joke. It's a prank. Um, yeah, sorry. Um, let's see. I think. Okay, so we have this looking all right. Just trying to think, like, do I even want to? Okay, so if we have this point here, so this is the hypotenuse. Okay, so we have the hypotenuse here. So local height is equal to height reduction. And the angle would be the same. So local op is equal to math dot sine angle. Where'd that angle go? There it is. Angle math dot sine. And then local adjacent would be math dot cos angle. Okay, and then we'd be connecting that with okay, so from there, okay, pivot offset. Um, if pivot offset then else end. Okay, so we're, we are overloading this function. Actually, that's not true. Overloading is actually a very specific thing, which we are not technically doing here, but we are putting a lot of burden on this function. It has gone beyond its initial scope. Okay. Okay, so pillared tip CF. Local CF times cframe dot new size dot z dot z divided by 2. Okay, so we're going to, and then up size dot y divided by 2. So we're now at this point, and we want to create a part right there. Then local size is equal to let's see, pillar size. And I'm just going to move this over just for the heck of it. Pillar size. Is this the same everywhere? Did I just do that here? Okay, so pillar size is equal to so we're going to have it go up that much this way. Okay, we're going to keep depth, but everything else is going to be different. Thank you, Josh. I appreciate it. Thank you for stopping by. Let's see. And map, yeah. Thank you, thank you. Yeah, the biggest of CJ faces. Yeah, I'm going for a that villain Ant-Man 3 look, MODOK. But yeah, check this out. I'm actually really happy with how the window generation stuff is coming along. Currently, though, I'm struggling to. I'm trying to do it again on triangles, and that is our current goal. We're just right now. Step one is yeah. No, I mean, dude, you can have a copy of the code, but yeah, for the most part, it's definitely saving a lot of time. My hope is to flesh it out so that this like has a like when you go inside it, replace it with like a hollow version. And so that's the plan over time. And I will open source this eventually. It's just like actually getting around to it. It's kind of messy right now. So probably for the best that you don't use it. Yeah, no. I mean, in fairness, this one's more because I really just want to save time, but also keeping the scope relatively big. Because, at the end of the day, for me, it actually is more time saving to take an hour doing this, or 2 hours, I guess, doing this for then actually placing it for all three of, like all 4 or 5 of these buildings. So yeah, it everyone has their own efficiencies. Yeah, yeah. No, I mean, like it'll be cool once it's out. I think people will like it. It's just actually getting around to it. Okay, so what was it? So I need to make this. Okay, so in filling this part in right here, the adjacent part would be the height, which, and then the opposite part would be the depth. And then local pivot would be cframe dot new op. No, wait, I forgot this is, okay, so then it would be op here. Op divided by 2. Okay, now we're just gonna see how this goes. Okay, pillar tip CF. Left inner pillar tip pillar tip size. And here you can hear the type safeness. Yeah, no, check this out. I actually, I'm surprised this worked, to be honest. I have the class name as set to literal of either part or wedge part, and it can be nil. And like, it actually works. And I can even tell it, like, it just returns an instance because it accepts that, like, but if I changed it to like, let's see, it adds some weird stuff here and there, but for the most part, I'm actually pretty happy with it. Um, but yeah, let's see. Thank you, Kato. I appreciate it. The let's see, left inner, and then I'm just gonna multiply it by, okay, what was it? So if it's being applied on the X side, so okay, we're gonna try this and see how this looks. Oh, so I never multiplied the hypotenuse. So okay, so opposite. Okay, yeah. So times the hypotenuse, and then, oof, we were close, but not there yet. Okay, so it added it here. What is happening with that? Okay, well, first let's figure out why it's doing less on the. Oh, I know what's happening. It's because the size should be the Z axis. There, okay, so that's it. So now, okay, we almost got it. We also need to offset it by the depth. So then that would be the, see, let's try this. Close, we are close. We just need to flip it. Okay, how would I do this? Okay, let's try that, but then we're gonna add 180. Probably, I just could have put math.py, but I'm not smart enough in real time. Beautiful, perfectly flush with this. We did it using trigonometry. Yay! So yeah, we got that lined up. It's gonna be nice. Am I gonna revamp all the powers? Yeah, I'm gonna remake them for sure. It's as to new powers though, that's it's further down on the backlog. Mathematical. Thank you, Squid Stick. Good to see you here. It looks like Zone has a lot of riddles. Well, I'll have you know I have a game with a bunch of dumb jokes on the title screen. Hmm. Um, how would I best do this again for the right one? I guess just rotate it by 180 degrees. Um, draw a pillar, right. All right. So let's just copy this. We're going to go down and to the right, negative 180. What am I doing, guys? It's literally just the same thing. Okay. Um, let's try that. Oof. Okay. Not a bad first try. Looks like I need to flip this part to beautiful. Beautiful. Okay, nice. All right, so we've got these two clear points. Let's actually organize this a bit more because they share some math, and so we can actually clean that up a bit. Let's just try to move the duplicate code to the same. Okay, so now we can reduce that to just these. Beautiful. What else? What else? This is gonna fit. All right. So now we just got to do the actual final pillar right here. Um, okay. So hypotenuse. Oh, so these aren't inner pillars. These are just pillars. Where did I start putting an inner? Why did I do that? I'm dumb. Okay. Hypotenuse. That's how you spell it, right? Okay. So the pivot, let's just comment that out for a second while we figure out what we're doing. Okay, so if I wanted to do this, okay, how clever am I allowed to be? Okay, so let's actually, instead of redoing all that logic, okay, I'm going to have it return the pillar. Base part, pillar. And then what we're going to do is local pillar tip. What we're going to do is we're going to take this and using the, how do we get the hypotenuse of this one? So I guess it would just be the magnitude of the size, right? Um, let's see how it's going to look with the other, on the other rows with the wedge parts along. Yeah, no, that's going to be the big question. How does it actually look when you add it to these? We're going to have to be very clever with that. Um, yeah, no, for sure. And but even then, like the style matching is good, but also there's still variety. Like look at how this one looks compared to how this one. These two are actually kind of similar. But then you have like the one down here. You have this wall, like just even these two, like this one versus this one, same engine powering both of them, but they're just configured very differently. So, I think we'll be able to get some variety. That'll be pretty nice. Um, let's see, so non-symmetrical outfits, definitely, 100%. Um, okay. So from there, we have to get the hypotenuse length though for local hypotenuse is equal to, let's see, so math dot sine angle times size dot z. No way. Size dot z divided by math dot sine. Okay, full hypotenuse. So from there we can get, so, all right, so the local hype size is equal to vector 3 dot new. Let's see, what would even be the, let's see, like it'd be like a op. So it'd be op times the hypotenuse, so it'd be y times the pillar tip size dot z. Okay, so what have I been doing? Where have I been editing? Okay, so I think only here. That's z, hype size. Okay, so local hype CF is equal to that C frame times new size dot z, I guess hypotenuse dot 2. Okay, let's try this. Oops, wrong spot. Let's see how this looks. Dang it. Oh well. Okay, so let's try that again. C-frame dot angles. Let's see, would be, let's try that. Okay, let's try it this way. Did I mess up something? No, these are just very coincidentally near each other. Okay, so this, okay, so I should have chosen adjacent instead of that. Okay, let's try this again. Nice. Looks like I forgot to offset it by cframe.new minus op divided by 2. Okay, it should be plus op. Okay, so now, okay, it's perfectly flush with that. The hypotenuse itself, but that distance is wrong though. Okay, so let's think this through. So size.x times size.x plus, let's maybe I guess we just square it instead. Plus, no, but it's size.z plus size.y squared A squared plus B squared equals C squared. Beautiful. All right, y'all, we did it. Yay. Ah, that was a headache. Okay. All right. That was painful, but I am proud of it now that it's working. Hmm. Okay, so now that we have this, we need to go through and now that we have this, let's actually just turn it off entirely and go back to solving the original problem. We're just going to leave that as it is and solve it this way. Okay, so now we are going to, how many pillars will this have? So this will have, okay, so max windows, dun, 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 dun. Actual window segment size. Okay, so let's go forward and do this part first. Okay. Okay, so wall segment size, origin 0. Okay, so from there we add 1, bam, bam. Nah, but wait, we gotta add the we gotta actually wrap it around. Okay, okay, so let's see. So we should do it dun, dun, dun. Okay, so we actually want to do this instead. And then if it's at the halfway point, we just want to work around that. So wall segment size, no. So we want to get the height at every single point. Local X start dist, X finish distance is just the start dist plus the column width, goal actual floor, tower config pillar dot width. Okay, so X finish distance. If X equals 0, then else if X equals max X windows, then okay, so plus pillar width. If X is equal to to 0, then pillar width 0.5. If it is max windows, then and the start distance. Okay, so minus pillar width. Okay, so x, yeah, 2 plus 2, 5. Dang it. Should have known it was 7. Wall segment C frame. Okay, so origin times x times. Okay, so let's just delete these. Let's see. Local pillar height is equal to math dot. Oh, just got a nice message from my wonderful girlfriend. Yeah, sorry to flex on you. Let's see, pillar height. Pillar height. What was I thinking about? Okay. 2 plus 2 that is true actually. Yeah. Yeah, one of the few instances of that. In fact, I think the only one. Yeah. So let's see. So how do we get the height at this distance? So if we assume that, let's just assume that we're going from right to left for now, just because that makes it a little bit easier. I never doubted that for a second, Cato. Um, so math dot cos, that would be tangent. Math dot tangent angle, cutoff angle. So times adjacent. So that would be x start dist, draw pillar, local pillar size is equal to vector3 dot new depth times 2 width local pillar CF is equal to the origin times cframe dot new x start dist plus pillar size dot x divided by 2, 0, 0. Okay, so from there we should have pillar size, name. Okay, see how this goes. Dang it. Mistakes were made. Okay, I forgot to pillar height divided by 2, so that's part of it. Okay, while I'm at it, I'm going to make the width and depth, the width and depth a little bit different. So let's have the depth be like 0.25. That should make it a little bit easier. So we're just rotating it essentially. Okay, so let's see how this works. Close. Nice. Okay, so it looks like we have that going. And we should only do this if the pillar height is above 0. If pillar height is above 0, then end. Okay. So now we have the so we have this part down. That's cool. Okay, so we have the pillar width, and actually let's okay, just because it'll be fun to look at. Check out has corner pillars, and it still kind of works. But no, I have to modify it so that has corner pillars. Okay, so if has corner pillars. I'm gonna have to use it again. Okay, so if has corner pillars, then put this in the wrong spot. Else, okay, so if corner pillars, then I guess we can just make this one statement. The x start dist minus equals okay. So now let's finish up this part. So if local pillar tip height is equal to x finish distance times the cutoff angle minus pillar height, and if pillar tip height is over 0, then okay, so wedge part The ultimate superpower claimed by Zone. Thank you, Kato. I appreciate it. Okay, so let's just, okay, so we have so this part's pretty much just modifying the origin in a way that makes sense. Okay, so C frame X start times pillar size dot X. Okay, so X start dist plus pillar size dot X and a half. So that should still be true. Oh, but no, but since this is a wedge part, it has to be the depth. No. Let's just run with this and see what happens. I don't think it's going to be right, but I think it's going to be. Okay, so let's start by just getting the positioning of it right. Okay, so pillar height divided by 2. So we need it to have pillar height plus pillar tip height divided by 2. Okay, so what is happening? Okay, now we just need to change the size of it to the pillar tip height instead. Okay, progress. Okay, also, I'm genuinely getting tired of this visualization. Let me try that. Okay. Okay, so we need to rotate it. So let's try this. Okay, why is the height all messed up now? Okay, I'm just going back. What I had before was closer. Okay, so I just need to rotate it and then swap the X and Z. Okay. So pillar CF times equals C frame dot new math dot red 90. What? What is going on here? Oh, C-frame.angles. I was like, there's no way that should have changed the position. Okay, so we have that part down. And now we just need to swap the X and Z. So pillar size is equal to, oh wait, I need to start naming this properly. This is vector3.new. Okay, beautiful. Look at that. It's perfect. Okay, let's see how it looks when I turn on corner pillars. That is very nice. Let's see. Yeah, stuff is all right. Congrats on being dad of the year. #1 dad mug coming your way. Yeah, no, the pillars of Christ Terminator uh, says asked if there will be trains. I want to add like a subway or something, I think, but that might but trains because this map is pretty small, trains might make more sense for like superhero like 4 or 3 or just something with a bigger map, you know? It's corner pillars. That's very nice. Okay, so the pillar size, so that looks good. Okay, so now all we got to do is this again, except just got to do this again for y. Okay, so y equals 0, max y floors. Okay, so actually let's just, I'm just gonna, we're just gonna write it from scratch. I was trying to be fancy and reuse the code. It's like, no, there's a bunch of stuff baked into it that I didn't think through. Okay, y equals, so max y floors. Okay, so what we got to do first is we got to handle the, okay, so if y equals 0, then local start height, let's see, how did I say x start dist? Okay, so y start dist is equal to, I guess, y times actual floor height. And then floor height or y ledge height is equal to, the ledge height is equal to tower config dot ledge dot height. And I guess for both of these, if pillar width is over 0, then okay, so if ledge height is over 0, then we'll do that stuff. But okay, so else if y equals max floors, then let's see. Okay, so generate all of this. Okay, so with that in mind, okay, so if it's 0, then we really just want that to be, okay, so maybe we should do this, so if it's the top, then its ledge height should actually be the, if it's the top, the ledge height should be the window height minus the, so tower config dot, so, or I guess actual floor height minus tower config dot window dot height minus ledge height. Okay. And then the start dist should go back that by that. Else, okay, so that works, I think. Okay, so if ledge height is over 0, then do that. So, okay. Okay, so now we're going to get the local ledge width. And that would be, okay, so if we have opposite, so cutoff angle, so that would be, so if we have this part, okay, so it'd actually be y start dist divided by the tangent. Let's see. What if there were bus stops that work like fast travel points? I mean, I think having fast travel be through I don't know. I don't like fast travel. I'd rather just allow you to have fast vehicles, or fast superpowers. I don't know. Realistically, if I ever had a game where like it would literally take the fastest thing, super long to get across it, that'd be different. But for the most part, most Roblox maps can be reached to the other side pretty quickly. So I don't know. I don't think I'm going to be adding fast travel. But having an automated bus system, I think, could be fun. But that would just come after automated cars, which would probably take a while. But still would be fun to have. So you can like punch them and have them go flying, and all the other cars swerve and panic. Okay, so why start this? Okay, so local y finish dist is equal to y start dist plus ledge height, ledge width. Okay, and then, okay, so if ledge width over 0, then So if ledge width is over 0, then we can have the local ledge size is vector3.new. Okay, so the ledge size, that would be ledge width, tower config, ledge.height, 2 times tower config, ledge.depth. Oh wait, no, we need to have ledge height be this one. Yeah. All right. The motorcycles are fun. Just having more vehicles in the game would be cool. Like I need to make up for the years of that Superhero Life 2 car barely functioning. Okay, so ledge size. Okay, so local ledge CF would be the origin times cframe.new, or after a brief rotation. Okay, so origin, so times cframe.new. So we need to go y start dist plus ledge size dot y divided by 2, or how would just do ledge height divided by 2, because that's what it really is. So y start dist times ledge width divided by 2. Okay, so now draw ledge. Okay, so we have to make a quick copy of this called draw ledge. Wedge depth is never used. Oh, interesting. Okay. So now draw ledge. We should probably refactor this at some point to reuse some code, but you know how it is. So pillar dot size. Pillar. Okay, that should work. I know. I'm sorry, y'all. I know that we should just copy entire functions like that, but I'm refactoring later. I'm already committing to a refactor. We just want to get the logic down right first before we, completely jump ship to that. Talking about vehicles, it would be nice to have an option to lock your vehicle so you can go into. Yeah, yeah. No, have just an entire. I need to set back and like make an entire permission system for my games, just so that you can have stuff like, who can enter your apartment, who can control the vehicles, who can see you on the map if there's ever a mini map. This is cool, but not what I was hoping for. Okay, so how do I even? Okay, so let's try this again. What is the origin set at? Okay, let's try this. That did not work at all. Okay, let's we're making progress. Nice. So because we now have both, then we should probably change the colors a bit. Okay. Okay, so the distance should use the, I guess we should use the start distance then. Okay, that's better. Hmm. It's offset a little bit. Okay, so is this 1? It's 1, 2, 1, 2, 3. So the maximum. Okay. Okay, so now if y is less than max y floors, then the underledge mistakes were made. Okay, so 1, okay, so 2, so it needs to, else. Some Nightcycles. I'm not thinking this through, am I? I'm not. Okay. I've just completely broken my mental model of what I'm doing. Okay, let's just start by not even approaching that. So ledge height, we should make it so that this fits the mental model of what we're actually doing. Okay, so we have this. It okay, so this ledge is too far down. So the ledge itself needs to be start distance I think I've been doing this wrong. Okay, so we should have it be that the one is down here, you know? Why start this? So, okay, so now let's remove all the weirdness. So we're just bringing it back a little bit closer to the original mental model. Okay, so 0, 1, 2, 3, 4, 5. Okay, so now we need to skip this to go the other direction. Is that right? No. Let's try it like that. Close, but no. So plus, so 0, Okay, nice. Okay, so that makes a little bit more sense. Now, hopefully, okay, so how far down does this go? So is this, so it's all the way at the bottom. Okay, so that's looking fine. Problem is, we need to actually have it droop down. So, okay, so we're going to take the logic of it. So if y is over 0, then we're going to have it at the local overhang, which is the actual floor height minus the ledge height minus the window height, which is tower config.window.height. And we're going to have it add that to the overhang. Okay, so we're going to have it add the overhang to the ledge height, but then we're going to have it subtract the overhang from the starting disk. And that should lead to, hopefully, that. Okay. Seems like we're no longer doing this part correctly, though. So, okay, yeah, so now we're locking in that part correctly. I think that because it's replacing the original, there's always going to be some controversy. Like some people are just going to not like it and miss the old one. But I think that so long as I make the old one available in open source pretty soon, that should be fine. Okay, that's the hope at least. Okay, so dun, 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 dun. Um, so this is looking all right. And now we just have to handle the situation at the top where if so if y equals max y floors do, or no, then we should subtract the underhang. And ledge height, okay, so ledge height minus equals ledge height. And the that didn't seem right. Maybe I don't. Okay. Hey there, Real Dragon King. Thank you for stopping by. When I remaster Super Hero Life 3, what's gonna different than Super Hero 2, and what I think for the most part it'll just be an opportunity to sort of flesh out the like porting over the Superhero Life 3 powers and the city itself. I think that those will be the main ones. Functionality wise, I might tackle a jobs system because I know that game had jobs. Just like I just want it to be, I want it to be faithful to the original, while also reusing as much functionality from the prequel. I guess not. I guess not prequel. The previous sequel. Yeah. So, well, but at the end of the day, though, we're just gonna have to come to that bridge when we get to it. No, across that bridge when we get to it. That's the phrase. Okay, I'm going to try. I want to quickly turn on the. I start this to make it overshoot it so I can verify that I'm getting my math right. All right, looks like I am. Well, actually, wait. Let me verify that I am. Just take a little bit more of a distance. All right, cool. That's looking good. Okay, so now, um, okay, so um, local ledge tip width is equal to y start distance minus ledge width. Okay, so then from there, ledge size okay, so ledge tip width ledge tip size. Okay, so now we will just draw this over. Looks like we are at the final 15 minutes. Um, Ledge tip. Let's see how this looks. Okay, so plus ledge height. Let's give it a go. Dang it. I was so close to being smart. I was so close. Okay, so let's replace this with, instead of ledge tip width, we should do okay. Let's try that. Let's try that. Beautiful. I have it drawing a pillar right now, so I need to change that. Beautiful. All right, we have it. We've done it, y'all. This is beautiful. Woo! It has corner pillars. Yes, it does. That is fantastic looking. What a cool little device. Okay. Let's see. But yeah. Hey there, Jimmy Dogwets. Welcome back. Amazing name, amazing introduction. Let's see. Rio Dragon King asks, what my inspiration for Nightcycle name and logo? Well, it's a mix of a few things. The first one was I I love biking, especially at night. I like I just like the night in general. It's very calm, peaceful to me. And I growing up, I would bike a lot of times at night. Um, Usually after telling my parents that I was going out. Sometimes I would just do it secretly though. Uh, Backfired once. Apparently, it's suspicious for a teenager to bike around in the middle of the night. Um, so one awkward police ride home, and I had to, you know, have an awkward conversation with my parents. Um, but yeah, no, but I like, I guess CJ Lordrop. Um, yeah, no, I just like biking at night. That's probably the biggest part. I also really like the part of, the whole enjoying the night theme. One of my favorite paintings is Nighthawks by, was it Ed something? Obviously, I'm no art expert, but I remember I remember the name Nighthawks because I thought that was a really cool painting. And so I was like, okay, what do I name my studio? Well, here's my favorite painting. This is something I love doing that, it's been part of it. And actually, a lot of design decisions, like if I'm ever stuck on a problem, just going on a late night bike ride helps me clear my mind. So yeah, so Nightcycle. And, as a bonus, it just has a cool sound to it. Um, but yeah, so, okay, can I just do this? And, okay, we're gonna have to, okay, so we have this part done. Let's see, with the final 10 minutes, let's see if we can get a version that is, okay, so tower generator, tower guide. Let's see, tower generator. So I'm going to make a new one called tower wall guide, and we're going to have that be put under the, just slow down the scrolling speed when it's this small. Okay, so map object, roads, there it goes. Okay, so um, group that one in the tower generator. 1 minute, let me just sync up the, that. Okay, so uh, plugins convert part. Okay, so now we're actually going to have it generate a wall instead of just local function render wall tower made. Okay, so where do I have it put the logic for which one it actually sends it? Okay, so if guide has tag, okay, local tower wall tag equals tags.tower generator tower wall guide. Okay, so we're going to combine that. Where do we put this? Okay, so if it has that, then and render what render wall tower made. All right, so render. Actually, we're going to want to do this too. Okay, so we're just going to organize this a little bit more forward thinking. Hey, nice. So now we're just going to copy over this code. Okay, so we're going to copy over this code, and we're going to call it render wall. You're my render wall. Okay. Okay, so first things first. Okay, so it's like OBS had a spasm. Also, we no longer have to do any of the tip stuff, so that'll be handy. Okay. Okay, so that's left pillar. Right pillar. Let's see. Let's see. Okay. I should combine these, but I'm not going to. I'm so confused. Okay. Something weird's happening. I'll tell you that much. Okay, so C-frame times size.x. Oh, wait, I think it's because I need to do it like this. Let's try that. In fact, let's just remove these different ones. All right. But I think